Okay, what we need to know about forces is that a force can change the shape of an object, or it can change its motion, the way it's moving, or its state of rest, whether it's stood still or not. Now, I've not written that down on this presentation, but you just need to know that it can change the shape of an object, it can change its motion, the way it's moving, or it can change its state of rest. So if it's stopped moving, it can make it move. If it's moving, it can stop it. That's what forces do. And the other thing you need to know is that whenever two objects interact, so for example, this human being and the floor, they exert equal and opposite forces. Okay, so if I click onto this now, you can see the expression equal and opposite. This is a really good phrase to use in the exam. And if you notice, the forces are equal in size. The length of the red arrow should really be exactly the same length as the green arrow. It's just slightly a bit shorter. They should be the same size, okay, but they're in opposite directions. So make sure that you say equal and opposite. It's no good saying the forces are equal, because they're not equal. They're pointing in different directions. So you need to say equal and opposite. Right, if we look at a boat, for example, this is a bird's eye view of a boat going on some water, and the boat may experience a number of forces. First of all, it's got the thrust. The engine is running away, and it's making it's giving it some sort of forward force. And of course, you've got friction acting on the boat, dragging it back. Of course, the wind may be acting on it in a different direction, and the current may be acting on it as well. So all of those four forces can interact in a certain way. You'll know that. You know, if you've got a really powerful wind, it'll cause your boat to go in a different direction. It is actually possible to get those four forces and replace them with one single force, and that force there is known as the resultant. So that's another good word to use, a resultant. And if you notice, it says lots of forces can be replaced by a single force. In this case, you can see that the boat is heading off towards like a 2 o'clock direction compared to north, because the thrust forward is moving it forward, but the wind and the current are pushing it northwards. For example, in a tug of war, you could have a team that's equally matched, each pulling the same amount. Then you get a big fat lump like myself, Mr. Dodds. I'm a big kind of guy, and then what you find is obviously my force, which is going to be quite large because I'm a big chap, would actually increase the force to the right hand side, and it'd be the equivalent of, say, Mr. Dodds just not pulling on anything at all. The resultant would be equivalent to my size. Right, so if you've got a resultant force, if you've got a force, what does it do? Well, if the resultant force is 0 and you apply it to a moving object, so if an object's moving and the resultant force is 0, in other words, there's no resultant force, it will keep on moving with constant velocity. Now, students find this hard to understand. Basically means an object will keep moving forever and ever and ever in a straight line unless an unbalanced force acts. Now, this is not what you normally experience, because you know very well that if you're in a car and the car's moving and you don't apply a force on the engine, it stops down. Well, that's because there is a force acting on the car. It's the friction. But if you got rid of that friction, it would just go on forever and ever and ever. If you throw a ball into the sky, you know very well the ball falls down, doesn't it? But if that gravity didn't there, if the resultant force was 0, that ball would go in a straight line forever and ever and ever, and its speed would not change. If the resultant force is not 0, so if you've got a resultant force, what it does to the object is it actually causes it to accelerate. You must remember that if this resultant force is not 0, the object will accelerate, it'll get faster and faster, and it will accelerate in the direction of the resultant force. We'll be doing something on this in free fall in a second. Right, if we look at a stationary object, if you've got an object that stood perfectly still to start with, if the forces on it are opposite and equal, there is no resultant force. The resultant force is 0, so the thing will stay still. It'll stand still. Now, previously we looked at when the object was moving, if the resultant force was 0, it would keep on moving forever, and that catches a lot of people out. They think that if something's moving, there must be a force acting on it. No, not necessarily. An object will just keep on going forever and ever in a straight line, unless acted upon by an external unbalanced force, a resultant force. But of course, it's very difficult to get rid of friction on our planet, so we don't see it quite so often. If the resultant force is not 0, in other words, if there is a force acting on an object that is stood still, the object will accelerate in the direction of the resultant. So let's imagine we had a wheelbarrow there, and there's friction acting against it, and a push is suddenly applied to it that's greater than friction. It will start to move, but you should really say it starts to accelerate. So if it was stood still, and then you applied an unbalanced force, in other words, one force bigger than the other, you would have a resultant force, and that would cause the object not to move, but you should say it accelerates. If you said it just moves, you might not get the mark. If you said it accelerates, you will get the full mark. And that is all about resultant forces.